Hello friends, once again welcome back to Advanced Mathematics 2. Friends, yesterday we have discussed about Laplace transform, right? I think we have discussed about why we want to use a Laplace transform, right? And how we are going to define a Laplace transform mathematically. Is it clear? Right? Say for example, if I want to write down a circuit in the form of equation, right? Now usually we will write down a circuit or a complicated circuit in the form of a differential equation. Then immediately I will search the methods, right? I know some methods what I have studied in the earlier classes, namely variable, separable, homogeneous method, exact method, linear method, etc. As clear. Suppose if I want to solve a non-linear equation or a non-homogeneous differential equation, right? So in that case, first I want to find out a complementary function, then I want to find out a particular integral, right? Then only I am expecting, or then only I am able to write down a general solution of the non-homogeneous equation. Is it clear? Right? So instead of using those methods, right, suppose if I use a Laplace transform method, right, then immediately I can convert an ordinary differential equation into an algebraic equation, right? And if I solve an algebraic equation, immediately I will get the general solution of the given differential equation. It means when we compare with the earlier methods, Laplace transform method is the most easiest method to solve an ordinary differential equation. That is one reason why we want to go for a Laplace transform. Is it clear? Right? Now as I have mentioned in the last period, what do you mean by a Laplace transform? Right? So it is the transformation, is it clear, from one plane to another plane, right? So I have mentioned left hand is one plane, right hand is another plane. Say for example, left hand you may treat it as an T space, right? Right hand you may treat it as an S plane, right? So now I want to transform the function from left hand to right hand, right? So it means left hand is a parameter T, right hand is a parameter S. That's clear, right? So T means time, here S means it is a frequency. That's clear. That's why we call it as an time domain and frequency domain. That's clear, right? So it is exactly similar to differentiation and integration. That's clear, right? So suppose if I want to find out derivative of the given function, that's clear, right? So then I will apply an operator, say D, to the given function, then I will get the function, another function. Is it clear? Right? So if I apply integration to the given function, then I can obtain another function. Is it clear? Right? So it means here D is an operator. Exactly in the similar way, here I can apply L, capital L. Right? So capital L is an operator. I can apply L on the given function. Is it clear? Then I will get another function. Is it clear? Right? So usually we denote L of f of t. F of t means we will use usually small letter, small f of t. Is it clear? Then I can obtain a function of S, capital F of S. Is it clear? Right? So then you may ask one question: for each and every function, is it possible to find out Laplace transform? Right? So answer is no, because given function must satisfy the condition, as I have mentioned in the last period. Is it clear? So given function must be an piecewise continuous, and it should be an exponential order. Is it clear? Right? So if the given function is piecewise continuous and exponential order, right? So I have already explained what you mean by piecewise continuous. Is it clear? So in a given interval, or in a given interval can be divided into number of sub intervals. Is it clear? Right? Then in each interval function should be continuous. Then we call it as an piecewise continuous. Is it clear? Exactly in the similar way, we want to integrate e to the power minus st into given function, right? So that we call it as an exponential order. If it satisfies modulus of given function is less than m into e to the power c into t. Is it clear? If it satisfies that condition, then we call it as an exponential order. Any function satisfies these two conditions, then we can say that function is eligible for a Laplace transform. Then you can evaluate integral, and finally you will get a function of s. Is it clear? And after that, I have defined a Laplace transform. So what is the basic definition of a Laplace transform? It is very simple. L of f of t is equal to integration of 0 to infinity e to the power minus s into t f of t dt is equal to a function of s. Is it clear? I think yesterday I have solved some standard examples. Is it clear? Right? So today I am going to solve some more examples on the definition or on the basis of the definition of a Laplace transform. Is it clear? Right? Suppose if the given function is sine 2t, right? How do we find out the Laplace transform of sine 2t? Is it clear? Right? So by definition of Laplace transform, so you can replace f of t by sine 2t. Is it clear? Right? So integration of 0 to infinity e to the power minus st, and again I have replaced f of t by sine 2t. Is it clear? Right? So when we observe this function, immediately I will come to know it is of the type product of two functions. Is it clear? Then I can go for integration by parts. Is it clear? Right? So you can keep first function as it is, namely sine 2t, and you can integrate e to the power minus s into t. Integration of e to the power minus s into t is what? E to the power minus s into t divided by minus times of s. Is it clear? Right? So because here s is treated as a constant, right? Plus 2 times of s into integration of 0 to infinity e raised to minus st cos 2t, right? Because I want to differentiate sine 2t, you will get cos 2t dt, right? So on simplification, you will get 2 divided by s 0 to infinity e to the power minus st cos 2t dt. Is it clear? Right? Here you should remember that s is greater than 0. Right? So that is equal to, I want to substitute the limits 0 to infinity. Is it clear? Right? So minus times of cos 2t e to the power minus st by s with the limits 0 to infinity minus 4 by s square 0 to infinity e to the power minus st into sine 2t. Is it clear? So after simplification, we can obtain 2 divided by s square minus 4 by s square into Laplace transform of sine 2t. Is it clear? Right? Or the same equation can be written as Laplace transform of sine 2t is equal to 2 by s square minus 4 by s square into Laplace transform of sine 2t. Is it clear? Right? So you can take out Laplace transform of sine 2t plus 4 by s square, Laplace transform of sine 2t is equal to 2 by s square. From these two terms, you can take out Laplace transform of sine 2t. Is it clear? So what we will get 1 plus 4 by s square is equal to 2 by s square, or the same equation can be written as Laplace transform of sine 2t is equal to, you can take the LCM, right? So simplify. So after simplification, you may get is equal to 2 by s square, right? Or Laplace transform of sine 2t is equal to 2 by s square into s square divided by s square plus 4. S square cancels with s square, and finally it remains 2 divided by s square plus 4, where s is greater than 0. It means that suppose if the given function is sine 2t, right? If I want to find out Laplace transform of sine 2t is equal to what I want to write, 2 divided by s square plus 2 square. Is it clear? Right? So instead of 2t, suppose they may give sine 3t. What is the Laplace transform of sine 3t? Exactly in the similar way we can prove, right? So finally what we will get, 3 divided by s square plus 3 square. Is it clear? Right? So if it is 4 instead of 2, suppose if they ask us to find out the Laplace transform of sine 4t, right? I can obtain 4 divided by s square plus 4 square. Exactly in the similar way, we can find out the Laplace transform of any function sine of either 2t, or you can replace 2 by any other constant, right. So, suppose if I want to draw the graph of a given function, is it clear. So, when you draw the sine 2t, is it clear, in t plane, as I have mentioned, we are going to transform a parameter t into s, right. So, I hope this is the graph of a time domain and this is the graph of a frequency domain, is it clear. So, what we will come to know that as time increases, is it clear, right. So, it is exponentially decreases, right, and here we can increase the value of s, right. So, as I have mentioned, s is the parameter, sometimes it may be a real or it may be a complex, right. So, if it is real, then you can give some values to s, according to that the function is goes on decreasing exponentially, that can be observed, is it clear. Suppose if you want to create this type of graphs, as I have mentioned in the earlier classes, right, I can create this type of graphs by using the software GeoGebra, is it clear. Suppose once you are able to create this type of graphs, right, here you can observe this small window, right. Here you can type any function, right. Here I have written sine 2t, right. Instead of sine 2t, suppose if you want to find out what is the Laplace transform of t, what we have explained or what we have obtained in the last session, right, or if you want to find out what is the Laplace transform of 1, is it clear, or what is the Laplace transform of t square, simply you can type the function, then immediately you will get a corresponding graph, is it clear, in both the planes, right. So, you can use a software namely GeoGebra, right. So, simply you want to type 4 or 5 commands in input bar, right. I am going to show you those commands, right. Say for example, in input bar in the software namely GeoGebra, you can type a command like this, input box, is it clear. So, this will create a box like this, right. In that box we can type any function, right, and after that, so we want to integrate, no, for that reason you can type integral exp minus s into x. Here x is a dummy variable, right. Instead of using t, here I have written x, right. So, e to the power minus s into x, is it clear, into b into x. B into x means in input box you can type any function. Suppose if it is t, it becomes e to the power minus s into x into x, is it clear, right. So, I want to integrate this function from the limits 0 to infinity. Suppose if I type a command like this in GeoGebra, so this command will integrate the function between the limits 0 to infinity, is it clear, right. So, as we have observed in this graph, right. So, now I want to create a right hand side function exponentially decreasing, is it clear. It is a point, right. So, it has an x coordinate and y coordinate, right. Now, I want to draw this point as well as this point, is it clear. How we are going to create those points? For that reason, you can create a point a is equal to s comma 0, right. So, I have mentioned you can give some values to s, is it clear. So, for example, if s is 1 comma 0, 2 comma 0, 3 comma 0. So, like that. So, this command will create a point a, right. And similarly, if you type in input box b is equal to s comma a, this will create another point b, right. Then you can draw a segment a to b. If you type this command, it will draw a line between a and b, is it clear, right. I hope you can observe a line segment in the previous graph, this line segment, right. So, a is one point, b is another point, is it clear. So, suppose if you type these commands, you can draw graph of any function, is it clear, right, and you can find out Laplace transform of any function in t plane, is it clear, right. So, now I want to find out the Laplace transform of one more function, namely cos omega t. Here omega is some constant, is it clear. You can replace omega by any constant, say for example 1 or 2 or 3 or any other constant. Is it clear? It means here the given function is cos omega t. Now I want to replace f of t by cos omega t in the basic definition. Is it clear? So before that, cos omega t can be written as 1 by 2 times of e to the power j omega t plus 1 by 2 times of e to the power minus j into omega t. Is it clear? So f of s is equal to, it means how we will get f of s is equal to, by definition of Laplace transform, 0 to infinity e to the power minus st, right. Instead of cos omega t, I will substitute the value of cos omega t into dt, right. So now I want to integrate this function. Is it clear? And it is a very simple integration, right. So I have written 1 by 2 constant outside into 0 to infinity e to the power minus s into t e to the power j into omega t, right. You observe base is same, I can add the powers. Is it clear? I hope you will get minus times of s plus j into omega t dt plus 1 by 2 times of you can multiply. Is it clear? E to the power minus st into e to the power minus j omega t, right. Again base is same, you can add the powers. Is it clear? I hope you will get minus s minus j into omega dt, right. So it is as good as integration of e to the power a into x with respect to dx. Is it clear? I hope very easily we can integrate, right. So that is equal to 1 by 2 times of integration of e to the power ax is what, right, e to the power ax, right, divided by a, right. So I hope you will get 1 divided by s minus j into omega plus 1 by 2 times of 1 by s plus j into omega, right. Take the LCM and simplify. I hope you will get s divided by s square plus omega square, right. Here r of s means a real part of s is greater than 0 and s is not equal to j into omega, right. So it means that Laplace transform of cos omega t is s divided by s square plus omega square, right. Suppose if you replace omega by 3, right, then what is the Laplace transform of cos 3t? It is very simple, s divided by s square plus 3 square, simply I want to replace omega by 3, right. So if it is minus 4, right, then you replace omega by minus 4, s divided by s square plus minus 4 to the power 2. Is it clear? If it is 10, then you can write down s divided by s square plus 10 square. So like that we can find out a Laplace transform of cosine of any constant into t. Is it clear? Right. So friends, this is one method to find out the Laplace transform of cos omega t. Is it clear? Right. So instead of using this form, directly you can substitute e to the power minus st into cos omega t. In that way also we can find out the Laplace transform of cos omega t. Okay. Now I think in the last session we have discussed about linearity property in differentiation and integration. Is it clear? So far we have obtained Laplace transform of a single function. Is it clear? Right. Suppose if the given function is sine omega t or cos omega t or f of t is equal to t or f of t is equal to t square, or in general given function may be t to the power n, or what is the Laplace transform of 1. Is it clear? Or what is the Laplace transform of e to the power at or e to the power minus at. Is it clear? All these functions are single terms. Is it clear? Right. Suppose if you have a function like containing 2 terms or more than 2 terms, how do we find out Laplace transform of 2 terms or more than 2 terms? Is it clear? Right. So we can find out the Laplace transform of 2 terms or more than 2 terms by using the property, namely linearity property. Is it clear? Right. So for example here integration of 0 to infinity e to the power minus st, right. Suppose if the given function may be in this form, in this form means what, right. So given function may be alpha into f of t plus beta into some function say g of t. Is it clear? So, in that case we can write down alpha is constant, we can keep as it is, integration of 0 to infinity e to the power minus st f of t dt plus beta into integration of 0 to infinity e to the power minus st z of t dt, right. So, whenever both integrals converge for s is greater than c, hence it follows that Laplace transform of alpha into f of t plus beta into z of t is equal to alpha into Laplace transform of f of t plus beta into Laplace transform of z of t. Is it clear? Or the same thing can be written down alpha into a function of s plus beta into another function say g of s, right. Here L is said to be a linear transform. It means linearity property holds good in case of Laplace transform. Is it clear? Right. So, now onwards we can use this property to obtain the Laplace transform of more than one term. Is it clear? Right. So, why can't we find out the Laplace transform of 1 plus 5t? Is it clear? Right. So, now you observe this function, it is containing two terms, namely 1 plus 5t. What is the Laplace transform of 1 plus 5t? So, by using the previous property, is it clear, I can apply L on the given function 1 plus 5t is equal to, you can apply L on term by term. How do we obtain differential operator d on the given function? Suppose if the given function is containing more than one term, exactly in the similar way here also I can apply L. Here L is an operator on term by term. Is it clear? So, that is equal to Laplace transform of first term plus a Laplace transform of second term. Is it clear? Here second term is 5 into t. 5 is what? 5 is constant, you can keep as it is. Is it clear? Laplace transform of t, right. So, that is equal to, what is the Laplace transform of 1? Yesterday we have obtained the Laplace transform of 1 is 1 over s. Is it clear? And 5 is constant, you can keep as it is, and the Laplace transform of t is what? 1 divided by s to the power 2. We have calculated what is the Laplace transform of L of t. Is it clear? As I have mentioned in the last session, we want to use those values as a formula. Now, I have used those values as a formula. Laplace transform of 1 is 1 by s, Laplace transform of t is 1 by s square, right. Now, again by using GeoGebra, so you can obtain the Laplace transform of 1 plus 5ut as well as 1 plus 5ut graphs using the GeoGebra, right. In all these cases, so what we can observe, it is exponentially decreasing function in s plane. Is it clear? Right. So, exactly in the similar way, suppose if the given function may be in this form, 4 times of e to the power minus 3t, is it clear, minus 10 times of sine of 2t, right. So, it means now we want to find out what is the Laplace transform of this function. Is it clear? Again it is containing two terms, right. First term is 4 times of e to the power 3t minus 10 times of sine 2t, that is equal to 4 is constant, you can keep as it is, Laplace transform of e to the power 3t minus 10 is constant, keep as it is, Laplace transform of sine 2t. This is equal to, again 4 is constant, I will keep as it is, right. So, we know the Laplace transform of e to the power minus 3t. Is it clear? Now, yesterday we have obtained the Laplace transform of minus sine 3t. Is it clear? Is 1 divided by s plus 3, minus 10 is constant, keep as it is. Just now we have obtained the Laplace transform of sine 2t is 2 divided by s square plus 4, right. So, if it is possible, we can simplify, right. I hope. So, this is the Laplace transform of the given function. Is it clear? Right. So, or we can find out the Laplace transform of cos at. Just now we have obtained Laplace transform of cos omega t. It is exactly similar to cos omega t. Is it clear? As I have mentioned, f of t can be replaced by cos at. Is it clear? Right. Here I have not used the definition of cos at. Is it clear? And it is in the standard form e raised to minus st into cos at dt, right. So, directly you can write on this step, then you can substitute the limits and simplify. I hope you will get the same answer what we have obtained in the previous slide, namely s divided by s square plus a square, where s is greater than 0. So, this condition is very important. Is it clear, right. So, again you can replace a by any constant. According to that you can write down the solution. Solution is always in terms of s. Is it clear, right. So, now why can't we find out the Laplace transform of hyperbolic functions? Is it clear? Namely, what is the Laplace transform of cos hyperbolic at, right. So, in all these examples we will come to know that we are using the basic definition. What is the basic definition? Integration of 0 to infinity e raised to minus st f of t dt. Is it clear? So, what is the given function? Cos hyperbolic function, right. So, replace f of t by cos hyperbolic function. Is it clear, right. So, 0 to infinity e to the power minus st into cos hyperbolic at, and we know the definition of cos hyperbolic at, right. So, cos hyperbolic at can be written as e to the power at plus e to the power minus at divided by 2. You can multiply by e to the power minus s into t dt. Is it clear? So, this is equal to, now I will multiply e to the power minus st into first function, e to the power minus st into second function. Is it clear? Then I can obtain 1 by 2 times of Laplace transform of e raised to at plus Laplace transform of e raised to minus at. Is it clear? It is as good as Laplace transform of function f of t, right. So, this is equal to 1 by 2 is constant, keep as it is, and we know that the Laplace transform of e raised to at is 1 divided by s minus a, right. We also know that Laplace transform of e raised to minus at is 1 divided by s plus a. Take the LCM and simplify. So, what we can obtain? A divided by s square minus a square. Is it clear? You observe it is a function of s. Okay. Now, exactly in the similar way we can find out what is the Laplace transform of a sine hyperbolic function. So, integration of 0 to infinity e raised to minus st sine hyperbolic at is equal to. So, we know that sine hyperbolic at is equal to e raised to at minus e raised to minus times of at divided by 2. Is it clear? How do you get? Again by definition of a sine hyperbolic function. Is it clear? It is exactly similar to previous example, right. So, once again I have to multiply e raised to minus st into e raised to at. Is it clear? E raised to minus st into e raised to minus at, right. So, 1 by 2 is constant, so you can keep as it is. Is it clear? So, base is same, you can add the powers, right. I hope you will get these two terms. Immediately you can integrate. 1 by 2 is constant, integration of this function is 1 divided by s minus a, 1 divided by s plus a. Again you can take the LCM and simplify. After simplification, so you will get a divided by s square minus a square, right. So, here s is greater than modulus of a. Okay. Now, we are able to find out the Laplace transform of a hyperbolic function as well as sine omega t and sine at. Sometimes the given function may be a piecewise continuous function. Is it clear? As I have mentioned while defining the Laplace transform. Is it clear? Right. So, I have already given one example. What do you mean by piecewise continuous function? Suppose if the given function may be in this form, find L of f of t, where f of t is equal to 0, 0 is less than or equal to t is less than 3, right, or f of t is equal to 2, t is greater than or equal to 3. It means that function is 0 between the interval 0 to 3. Function is equal to 2 when t is greater than or equal to 3. Is it clear? So, this piecewise continuous function appears as follows, since f is defined in 2 pieces. Is it clear? They have defined function in this fashion. Suppose if I draw the graph of this function. What is the graph of this function? I hope now you are observing this graph. Is it clear? Right. So, you observe these numbers 0, 1, 2, 3, right. Function is 0. It means you will get the line on this line. This line means on x axis, or you can take it as an t axis. Suppose if you take it as an t axis, and you can take it as an f of t. Is it clear? Right. So, you will get a graph like this, then sudden jump. Is it clear? Then you can obtain 2, right, corresponding to 2, you will get a line. If it is greater than or equal to 3, I think this is the 3. Is it clear? Right. So, now I want to find out what is the Laplace transform of this piecewise continuous function. Is it clear? How we are going to find out? So far we have not obtained a Laplace transform of this type of functions. Is it clear? Right. Either it may be an single term, or it may be an more than one term, right. Then we have obtained a Laplace transform. Is it clear? Suppose if it is a piecewise continuous, how we are going to find out, right? It is very simple. We know the basic definition. What is the basic definition? L of f of t is equal to integration of 0 to infinity e raised to minus s into t f of t dt. Is it clear? So, now I want to replace f of t by given function. This function can be written down in this form. So, here what are the limits? Limits means what? You can write down t is equal to 0 to t is equal to infinity, right. So, it can be split into two parts according to the given function, right. I can write down 0 to 3 e to the power minus s into t. First part is 0, because in this interval the value of the function is 0. That is why I have replaced f of t by 0, plus another interval 3 to infinity, because they have given t is greater than or equal to 3, right. 3 to infinity e to the power minus st into 2, right. They have defined f of t is equal to 2. So, friends, I know that the value of first part is 0, because f of t is 0. It means now you want to evaluate only second integral, right. So, here 2 is constant, you can keep as it is. Integration of minus s into t, what we will get? E to the power minus s into t divided by s. Between the limits 3 to infinity, I have to replace t by 3 and t by infinity. Is it clear? So, what we can obtain? 2 times of e to the power minus 3s divided by s. So, because when we replace t by infinity, it becomes e to the power minus infinity. E to the power minus infinity means what? 1 divided by e to the power infinity. 1 divided by e to the power infinity means it becomes 0. Is it clear? Right. So, finally, you can obtain this answer, and it is a function of s. Always it is a greater than 0. As usual, you can draw the graph. Friends, you want to think in one more direction. Just now we have obtained the Laplace transform of piecewise function or piecewise continuous function. Sometimes instead of defining the function, so they may give signals, they may give a graph in this form. Is it clear? Right. So, they have given 0 to 1 is on this on t axis, right, and otherwise it is increasing like this, passing through the point 2 comma 2. They have asked us to find out the Laplace transform of this graph. What is the Laplace transform of this graph? Is it clear? Here first we want to write down the given graph in the form of a function. Is it clear? First we want to define the function, then only we want to obtain the Laplace transform of the function. Usually you will not practice this type of examples. According to me, we must practice this type of examples. Is it clear? Suppose if they give a graph like this, how do we write down a mathematical function for such type of graphs? Is it clear? And it is very simple graph. I hope we can write down f of t, or we can define f of t as follows, right. So, f of t is equal to, I will write 0 between 0 and 1, because in between 0 and 1, what is the line? So, it is 0 on the t axis. Is it clear? right. So, otherwise it is t when t is greater than or equal to 1, right. The graph can be written down in this form. Now, we have obtained a function, right. Very easily you can find out the Laplace transform of this function, because it is a piecewise continuous function, right. So, here f of t is known, and you know the basic definition. Replace f of t by given function, namely L of f of t is equal to integration of 0 to infinity e to the power minus st f of t dt. Is it clear? So, integration of 0 to 1 e to the power minus st according to the function in between 0 and 1, function value is 0. I can replace f of t by 0 plus another interval 1 to infinity, because they have given or they have defined t is greater than or equal to 1, right. So, I have to replace f of t by t e to the power minus st into t dt. Again first part becomes 0. Now, I want to evaluate only second part between the limits 1 to infinity. So, that is equal to integration of 1 to infinity e to the power minus st dt. How we are going to evaluate? So, once again I want to use integration by parts. Is it clear? So, by using integration by parts, you can treat t as the first function, e raised to minus st as the second function. That is why I have written here t into e to the power minus st divided by minus s between the limits 1 to infinity minus e to the power minus st divided by minus s, because if I differentiate t with respect to t, I can obtain 1. Is it clear? And finally, I want to substitute the limits. First part becomes 0, because e to the power minus st, I have to replace t by infinity. E to the power minus infinity can be written as 1 divided by e to the power infinity. Is it clear? That is equal to 1 by infinity, that is equal to 0. So, first part is 0, second part is not equal to 0, because I have to replace t by 1, right. Finally, so you will get 1 by s into e to the power minus st by s. Again I have to replace the limits 1 to infinity. Is it clear? I have to simplify. After simplification, so what we can obtain? We will get a function of s, namely e to the power minus s divided by s plus e to the power minus s divided by s square. Is it clear? So, like that we can find out the Laplace transform of a piecewise continuous function. Is it clear? Friends, we want to go back to the first example. Is it clear? It means so far we have discussed a variety of examples. Is it clear? Why can't we rewrite those examples in the form of formula? Is it clear? Suppose if the given function is 1, what is the Laplace transform of 1? Right. So, we know that the Laplace transform of 1 is 1 over s. Suppose if the given function is e to the power a into t, what is the Laplace transform of e to the power a t? It is very simple, 1 divided by s minus a, right. So, if it is t to the power n, what is the Laplace transform of t to the power n, where n is a positive number, positive integer. So, n factorial divided by s to the power n plus 1. Is it clear? So, if it is sine a t, what is the Laplace transform of sine a t? A divided by s square plus a square. What is the Laplace transform of cos a t? S divided by s square plus a square. Is it clear? What is the Laplace transform of sine hyperbolic a t? Is it clear? So, a divided by s square minus a square. Similarly, Laplace transform of cos hyperbolic a t is a divided by s square minus a square. Sorry, s divided by s square minus a square. Is it clear? Friends, all these formula plays an important role, because while solving some more examples, we may use these formulas. Is it clear? Right? Especially in case of inverse Laplace transform, we are going to use all those formula. Right? So, now I have planned to solve some more examples on the basis of a Laplace transform. Is it clear? Right? So, now we have discussed about suppose if they give 2 terms, how do we find out the Laplace transform? If they give more than 2 terms, we are able to find out the Laplace transform. Suppose if they give product of two functions. Product of two functions means, say for example, the given function may be t into sine at. Is it clear? Or a given function may be sine 2t into sine 3t. How do we find out the Laplace transform of this type of functions? Is it clear? Here immediately we want to refer the table. Just now I have given the table of a formula. Is it clear? Right? There is no ready-made formula for this type of functions. Is it clear? Right? So for that reason, what I want to do, I can say that a given function is not in the standard form. Is not in the standard form means, so if it is sine 2t, I can find out the Laplace transform. If it is only sine 3t, I can find out the Laplace transform. Here they have given that product of sine 2t sine 3t. Is it clear? That is why I can say that there is no ready-made formula. For that reason, now I want to rewrite it in the standard form. Standard form means I have to go through the table. Is it clear? I can reduce this function into a list of formula. Then I can use the corresponding value. I can declare it as a solution of the given problem. Is it clear? Right? So before solving, first we shall think how do we write down sine 2t into sine 3t. Right? So friends, we know one formula. What is that formula? Sine A into sine B can be write down 1 by 2 times of cos of A minus B minus cos of A plus B. So now we can use this formula. By using this formula, I can write down sine 2t into sine 3t is equal to 1 by 2 times of cos of A minus B means 2t minus 3t. Is it clear? I hope you will get cos of minus t. Right? So cos of minus theta can be written as cos theta only. That is why here I have written cos t only. Right? So minus cos of A plus B. A plus B means cos of 2t plus 3t. Is it clear? I hope you will get a cos of 5t. Right? So now it becomes the standard form. I can apply Laplace transform on these two terms. Is it clear? Immediately I will apply L on both sides. Is it clear? Right? So L of or Laplace transform of sine 2t into sine 3t is equal to 1 by 2 times of Laplace transform of cos t minus Laplace transform of cos 5t. Is it clear? Right? So 1 by 2 is constant, so you can keep as it is. Right? So Laplace transform of cos t is what? S divided by s square plus 1 square. Why it is 1 square? Because the coefficient of t is 1. Is it clear? That is why I have written 1 square minus sign as it is. Laplace transform of cos 5t. What is the coefficient of t? T is 5. That is why, so you can write down s divided by s square plus 5 square. Using the formula, I hope we can write down a Laplace transform of cos t as well as cos 5t. Remaining part is simplification, because we have obtained the Laplace transform of cos t and cos 5t. You can take the LCM. 1 by 2 is constant. Take the LCM and you will get in the numerator s into s square plus 5 square, or you can write down 25 minus s into s square plus 1 square. Is it clear? You can multiply. I hope after simplification you will get 12s divided by s square plus 1 into the bracket s square plus 25 or 5 square. Okay. So now we have obtained the Laplace transform of sine 2t into sine 3t. Is it clear? And sometimes so they may give a function in this form. Find the Laplace transform of sine cube 2t. Is it clear? Again, given function is not in the standard form. Is not in the standard form means, so we don't have a ready-made formula for this function. For that reason, now I want to rewrite it in the standard form, because so we know one formula, namely sine cube A is equal to 1 by 4 times of 3 into sine A minus sine of 3a. So we can use this formula. By using this formula, we can write down sine cube 2t is equal to 3 by 4 times of sine 2t minus 1 by 4 times of sine 6t. Is it clear? Then you can apply Laplace transform on both sides. Is it clear? Right? So Laplace transform of sine cube 2t is equal to 3 by 4 times of Laplace transform of sine 2t minus 1 by 4 is constant, you can keep as it is. Laplace transform of sine 6t. Is it clear? Right. So, we know the Laplace transform of sine 2t because it is in the standard form. So, 3 by 4 keep as it is, sine 2t is 2 divided by s square plus 2 square minus 1 by 4 is constant, keep as it is, right. So, we know that Laplace transform of sine 6t s divided by s square plus 6 square. Is it clear? Right. So, I think it is 6 divided by s square plus 6 square. So, because we want to find out Laplace transform of sine 6t. Is it clear? Right. So, that is equal to 1 by 4 times of, you can take the LCM. What is the LCM? S square plus 2 square, s square plus 6 square is the LCM. Is it clear? Right. So, 6 times of s square plus 6 square minus 6 times of s square plus 6 square. You can simplify, 3 into 2 is 6. Is it clear? And 1 into 6 is 6. Right. So, I hope after simplification, so you can obtain 48 divided by s square plus 2 square into s square plus 6 square. Again, it is a function of s. Right. So, sometimes the given function may be in this form, 3 times of sine 4t plus 4 times of cos 3t. What is the Laplace transform of this function? Right. It is also similar to previous examples. Directly you can apply L on this example. Is it clear? L on this function, Laplace transform of 3 sine 4t plus 4 cos 3t is equal to Laplace transform of 3 is constant, you can keep as it is. Laplace transform of sine 4t, 4 is constant, keep as it is, L of cos 3t. And we know that Laplace transform of sine 4t is 4 divided by s square plus 4 square plus 4 is constant, keep as it is. Cos 3t is s divided by 3 square, s square plus 3 square, right. Again you can take the LCM. What is the LCM? S square plus 4 square, s square plus 3 square. So, that is equal to 12 times of 3 into 4 is 12 into s square plus 3 square, right. So, 4s into s square plus 4 square, multiply 12s square, 12 into 3 square, 4s into s square, 4s into 4 square. Is it clear? I hope we can obtain numerator and denominator. Finally, after simplification, so you can obtain the function of s. Friends, here what we want to remember in all these cases, you should remember the basic formula. What is the basic formula? L of f of t is equal to integration of 0 to infinity e raised to minus st f of t dt. I want to replace f of t by given function. Is it clear? Then next step is I want to think whether the given function is in the standard form or not. If it is in the standard form, then directly you can apply L. If it is not in the standard form, first we will try to write down in the standard form. Is it clear? Here you can observe one more example. It is given that cos square 2t. Is it clear? Immediately you can say that so this is not in the standard form, because we know that cos square a is equal to 1 by 2 times of 1 plus cos 2a. By using this formula, you can rewrite cos square 2 times of t in this form, 1 by 2 times of Laplace transform of 1 plus 1 by 2 times of Laplace transform of cos 4t, right. So, 1 by 2 is constant, keep as it is. So, we know that Laplace transform of 1 is 1 over s plus 1 by 2 times of Laplace transform of cos 4t, again it is s divided by s square plus 4 square. Is it clear? 1 by 2 times of 1 by s plus s divided by s square plus 4 square. Is it clear? Again 1 by 2 is constant, s square plus 4 plus 8s divided by s into s square plus 4. So, it means again it is a function of s. Is it clear? So, instead of two functions, suppose if the given function may be in this form. In this form means, so suppose if they give product of three functions, cos t, cos 2t, cos 3t, how do we find out the Laplace transform of this type of functions? It is very simple. So, when we use product of two functions, in that case you can use cos a cos b formula, because all the functions are cos t, cos 2t, cos 3t. Is it clear? So that is equal to 1 by 2 times of cos of a plus b plus cos of a minus b. You can take any two functions, namely cos 2t, cos 3t. A plus b means 2t plus 3t, phi ut. Is it clear? So you can write on cos phi ut. And similarly, a minus b means you can write on cos t. Apply Laplace transform on both sides, or before that you can find out cos t into cos 2t cos 3t. So you can write down cos 2t cos 3t in the form of sum of two terms. When you multiply one more function, again it becomes a product of two terms. Once again you want to apply the same formula. Is it clear? Namely cos a cos b. Is it clear? So here you can write down, or you can apply L on both sides. So you will get 1 by 4 times of Laplace transform of cos 6t plus cos 4t plus 1 by 4 times of Laplace transform of 1 plus cos 2t, because you will get cos square t. No, cos square t can be written down in this form 1 plus cos 2t by 2, right. So finally you can apply L on cos 6t. Cos 6t means s divided by s square plus 36. You can keep constant as it is, plus 1 by 4 times of s divided by s square plus 16, right, plus 1 by 4 s, right, plus 1 by 4 is constant. Laplace transform of cos 2t is s divided by s square plus 4, and again it is a function of s. Is it clear? Friends, so far we have solved a variety of examples on Laplace transform. In the next session, so we shall think about what do you mean by a change of scale property of a Laplace transform. Thank you very much for patient hearing.